Okay, let's be honest. We've all been there, right? You build this awesome Delphi FMX app for Android, and it just feels slow. It stutters when you scroll, it's laggy to the touch, and it's just plain frustrating. Well, today, we're going to change that. We are going to turn that lagging app into a fluid, high-performance experience. Let's dive right in.
That dreaded message. The ANR. For any Android developer, this is basically a nightmare. For our purposes today, though, think of it as Exhibit A. This is the smoking gun, the thing that tells us a crime against performance has been committed, and we're here to investigate.
That's right. For this explainer, we're treating this whole thing like a crime scene investigation. The slow app, that's our crime scene. The performance bottlenecks, those are the elusive culprits we need to track down. And our sources, well, they're the case file that's going to lead us straight to them.
So, this is the big question, isn't it? The one driving our whole investigation. We're not here to just put a few band-aids on the problem. No, we're here to conduct a full inquiry, to uncover the real root causes of poor performance and lay out a solid strategy to neutralize them for good.
Our investigation is going to start with the most common offender, the one who's pretty much always at the scene of the crime, the main UI thread. This is the single thread that's responsible for everything the user sees and touches, drawing the entire interface and responding to every single tap, swipe, and scroll.
And here's the crucial part. Any heavy lifting. I'm talking loading data, complex math, network calls. If you do any of that on the main thread, it just freezes the app solid. The user is tapping on the screen, and literally nothing is happening. This is, without a doubt, the #1 cause of a terrible user experience. Now check this out, because what's really wild is how incredibly tight our performance budget is. To get that silky smooth 60 frames per second, everything you do to draw a single frame has to finish in just 16 milliseconds. 16! And on a newer 120Hz screen, that budget gets slashed to a brutal 8 milliseconds. If you miss that deadline even by a little, you drop a frame, and the user sees that as a stutter, or what we call jank.
This analogy just perfectly illustrates the waste. Modern phones have these super powerful processors with 8 or more cores. Running your entire application on just the main thread is like hiring a world-class orchestra and then only letting the first violinist play. You are leaving almost all of your device's potential just sitting there, completely unused.
And here we go. This is our key piece of forensic evidence. When a background thread needs to update the UI, a lot of developers reach for tthread.synchronize. The problem? Synchronize is basically a stop sign. It forces your background thread to just halt, to wait for the main thread to be free. It creates this massive traffic jam. The right way to do it is tthread.queue. It just posts a message. Think of it like leaving a sticky note that says, hey, update this when you get a chance. And the background thread just moves on without ever stopping. It decouples the work, and that is absolutely essential for a responsive app.
Okay, let's move on to our next suspect. Sometimes the performance hits come from a place you'd least expect. The very tools designed to make our lives easier. These high-level components inside the FireMonkey framework, they can have a hidden and very high cost. See, FireMonkey's flexibility is its greatest strength, but it really comes with a trade-off. Under the hood, a simple T button is this complex composition of shapes and effects. The style system has to build these on the fly. And in a T-list box, every single item in that list is its own full-blown styled component. So if you have a list of hundreds of items, the overhead just to scroll becomes enormous. Even drawing a simple shape can end up rendering dozens of tiny triangles behind the scenes.
This quote from a developer on Stack Overflow really just sums it all up, doesn't it? The very architecture that gives FMX its amazing cross-platform power can become a major performance bottleneck if you're not aware of what's really happening under the surface.
All right, our third and final culprit is a bit more subtle, but it is just as deadly to your app's performance. It's a silent killer: memory management. How your app requests, uses, and frees up memory has a huge impact on whether it feels smooth or sluggish. Think about it like this. The older FastMM4 memory manager was kind of like having a single ticket booth for a sold-out stadium. Only one thread could request memory at a time, forcing all the other threads to just stand there and wait in line. But the modern FastMM5, it was designed for this multi-core world. It's like having multiple ticket booths with no central line, letting lots of threads get the memory they need in parallel without the wait. It's a game changer.
And this is a perfect analogy for why data layout matters so much. The CPU is your chef. The super fast CPU cache is the countertop right next to them. And the much slower main RAM, well, that's the pantry down the hall.
Every trip to the pantry costs precious time. So when you organize your data into these contiguous arrays, what you're really doing is putting all the ingredients the chef needs right there on the countertop. And the result? They can work much, much faster.
Okay, so our investigation has identified the three main culprits: the main thread, those deceptive framework abstractions, and memory management. We've seen the evidence. Now it's time to close this case and lay out the action plan to fix this problem for good.
So here it is, your 4-step blueprint for a high-performance app. Number 1, audit all your threading code and replace every single call to tthread.synchronize with tthread.queue. Number 2, for those long lists, cache your data and use simpler controls to avoid that massive overhead. 3, use a modern memory manager and actually verify its behavior. And finally, and this is the most important step of all, you have to profile your application.
You cannot optimize what you do not measure. Don't guess. Profiling tools like Google's Perfetto and Delphi-specific tools like ProDelphi are your treasure map. They don't just give you clues, they lead you directly to the X that marks the spot where your performance bottlenecks are buried.
So, after our whole investigation, after identifying the culprits and looking at all of the evidence, it's time. Time to deliver the final verdict on how to build genuinely fast, fluid FMX applications on Android.
Seriously, if you take only one thing away from this today, let it be this principle. Do not assume you know where your app is slow. Your intuition, I don't care how experienced you are, is often wrong. True optimization starts by measuring, by using a profiler to find the actual problems, and then methodically fixing them. And this is the ultimate takeaway. Performance is not a feature you can just sprinkle on at the end of a project. A truly responsive, fluid application is the direct result of an architectural choice you make from day one. It means you have to think in parallel from the very beginning to really harness the power of modern hardware. Which brings us to a final, more strategic question. We've seen the work it takes to really deeply optimize a cross-platform application. So at what point does all that effort, the low-level thread management, the deep profiling, working around framework limitations, at what point does that become more complex than just building natively for the platform that really demands that peak performance? That's a tough question, and it's one every development team has to answer for itself. Thanks for joining me.